Greetings to the Emertxe team and faculty and everyone watching this video. Myself Om Bharev, and today I will be presenting my internship concluding project titled Smart Factory IoT Monitoring System. This project was developed during my internship at Emertxe, where the goal was not just to make a small Arduino based demo, but to understand how a real industrial IoT system is designed from device layer to all the way to the cloud monitoring. This project combines multiple technologies together, such as embedded programming using Arduino Uno, sensor interfacing, simulation using the PicsimLab, cloud connectivity using MQTT, ThingsBoard dashboard, then alarm generation, remote device using RPC. Then this project is not only about monitoring sensor data, but also creating a complete smart factory monitoring architecture. The system has two simulated IoT nodes, Node 1, Node 2. The first node represents the production line where machine-related conditions are monitored, and the second node represents the warehouse where the environmental and security conditions are monitored. Both these nodes send live telemetry to the cloud every 5 seconds. The data is visualized on the ThingsBoard dashboard. Alarms are generated automatically based on the thresholds, and some control actions can be triggered remotely. During this presentation, I will be explaining the complete system from architecture to implementation, and I will also demonstrate how the simulation works in PicsimLab and how the cloud dashboard responds in real time. Now, the agenda. In this presentation, I will cover the project step by step. First, I will explain the project objective and then the industrial problems it addressed. Then I will be explaining the system architecture and how the edge devices communicate with the cloud. After that, the explanation of hardware design of both the nodes. Then I will explain the software architecture and the code structure. Then I will demonstrate the simulation environment using the PicsimLab, and in this I will also be explaining how the MQTT is used for cloud communication and how the ThingsBoard is used for dashboard and alarm. After that, I will be explaining the testing results and the reliability features. Finally, I will conclude on technical learning that I gained during this internship. And the idea is not just to show what was built, but also how it was designed, tested, and what I learned by building this. Now the project overview. The main idea behind this project is to simulate a smart factory monitoring system. In industries, operations need to continuously monitor machines and environmental conditions. For example, is the temperature rising? Is the machine vibrations abnormal? Is the humidity very high? Is the ventilation required? Or is there is an unauthorized motion in the warehouse? Or is a door unexpectedly open? Normally, monitoring all this manually is difficult. That is where industrial IoT helps. Collecting the sensor data, controllers processing the data, cloud platforms visualizing the data, then the automation can react when something goes wrong. That is exactly what this project demonstrates. This project has 5 main use cases. First is the real-time monitoring. Operators can see live value from both nodes. Second is the automatic ventilation. If the humidity reaches 85%, ventilation starts automatically. Third is the remote control. An operator can use the dashboard to send command and switch a relay remotely. Then fourth is the security monitoring. The motion and the door activity in the warehouse can be tracked. Fifth is the fault handling. In where if a sensor or a network disconnects, the system handles it safely. So this project combines sensing monitoring, automation, alarms, and reliability features in a one system. Now comes the system architecture. The three-tier system architecture consists of this first layer as the perception layer. This is the edge layer. This is where the Arduino nodes, sensor relays, and LEDs exist. This is where the data originates. Node 1 and Node 2 both belong to this layer. The second layer is the transport layer. This is where the data is transmitted. In this project, the communication protocol used is MQTT. MQTT is a lightweight, efficient, and widely used protocol in IoT. The Nodes publish telemetry data to the MQTT broker. The third layer is the application layer. This is the cloud side. Here the ThingsBoard receives data, stores the data, creates dashboard and generates alarm and handles the RPC commands. So if I simplify the flow, the sensor reads the data, Arduino processes the data, MQTT sends it, the ThingsBoard displays the data. Operator monitors, then after that operator monitors the data and optionally sends commands back. Then this flows completes. This architecture is important because it is scalable. More nodes can be added later without redesigning the entire system. Node 1 production line. Now, now I will be explaining the production line node. This node simulates the monitoring of machine conditions. The DS22 sensor measures air temperature and humidity. The LM35 measures the machine surface temperature. This is important because machine surface temperature can be indicate overheating. The vibration is simulated using the potentiometer. This represents the machine vibration or abnormal mechanical movements. A push button represents machine on and off state. The relay simulates the machine control and LEDs show house status. And the green LED means everything is healthy. The yellow means warning and red means there is a fault. The vibration input is averaged out using 4 ADC samples. This improves stability. The LM35 uses a formula. The ADC is multiplied by 500 and then divided by 1023, which is the max value. That converts the ADC into temperature. This slide represents the sensing and the local control available at the production line. Node 2. This node represents the warehouse. This node is focused on environment and security. The DHT22 measures the temperature and humidity. The PIR detects motion. The read switch detects whether the warehouse door is open. The LDR detects whether the warehouse is dark, and the relay controls ventilation. The important feature here is automation. Where humidity reaches 85%, ventilation starts automatically. That makes the node intelligent. Another important feature is the PIR hold logic. Instead of motion flickering on and off rapidly, the motion stays active for 10 seconds after the last trigger. This improves dashboard reliability. So this node combines the environmental monitoring, security monitoring, and the automation. Modular code design. Now the software design. Instead of putting everything inside one Arduino file, the code is split into modules. This is very important in embedded systems. Config file handles the constants. The sensor manager reads sensors. The actuator manager handles the output. Network manager handles the MQTT. The telemetry manager creates JSON payloads. RPC handler handles the incoming commands. This separation makes code maintainable and it also makes debugging easier. This is one of the biggest things I learned during the Emertxe internship. Good software structure matters as much as hardware. This is the code walkthrough. Now the program follows a complete sequence: checking the network, read the sensor, run the automation, update the LEDs, publish telemetry, process RPC commands, and then repeat. The telemetry is sent every 500 milliseconds, that is every 500 seconds. The timing is handled using millis function, not blocking delay. That keeps the node responsive. This is important because if delay was used excessively, network communication would suffer. And this is another important embedded concept thing I learned in this internship. PicsimLab. Now this is the main in which simulation software which is used to simulate all the project. So what is PicsimLab? It is a free open source simulator that runs Arduino at Mega 328p program on your PC. So you can just interact to the virtual sliders, LEDs, buttons, sensors, all virtually and behaving like exact hardware. It even simulates an Ethernet chip for MQTT networking. The virtual components has a very vast range which are available are like DHT22, temperature humidity slider, the LM35 which is used in the analog potentiometer, the PIR sensor, read switch, LDR, Ethernet, relay output, and RGB LEDs. So this is the deployment workflow of PicsimLab, wherein we write the code in the Arduino IDE with the PubSub client libraries and the THT libraries. Then we set the buffer size of the MQTT packet from 128 to 256 in the PubSub client.h file. Then we compile and export. We get a binary .x file which is then loaded into the PicsimLab by selecting the node 1 or node 2 file. We can load it into the PicsimLab. When we press the simulation, we can see the serial monitoring showing the data sent, and also we can then interact to the hardware components which are in the PicsimLab and can get the data in the cloud ThingsBoard dashboard. Now the MQTT and the ThingsBoard Cloud. Now the protocol which we have used in this project is the MQTT, which is Message Queue Telemetry Transport. It is a lightweight and publish subscribe protocol designed for IoT devices with limited bandwidth and memory. Devices publish data to topics and then ThingsBoard subscribes it. The port 1883, which is an unencrypted, is ideal for the simulation. So here we can see the setup which is used for the ThingsBoard. So first we create an account, then we add the device in which production line monitor and warehouse monitor is been added. Then we copy the access token and paste it into the config.h. Devices, the latest telemetry in all the keys appear in 10 seconds. There is a little bit of delay, but it is minor. Then we build dashboards, we import JSON files, and also we can create it by our own. Then we configure the alarms, then we add the thresholds and save it. Now what data gets sent to the cloud? So here is the list of data from node 1 and node 2. From node 1 we get the temperature, humidity, the LM35 temperature, vibration, machine status, relay state, sensor error, and the uptime. From node 2 we get temperature, humidity, LDR value, is dark, motion detected, door open, relay state, sensor error, and uptime. So these are the data which has been sent to the ThingsBoard dashboard from the PicsimLab. So next we will be seeing the demonstration of this whole project, how uh, the Arduino code is dumped into the PicsimLab, then how from that the data is sent via the MQTT to the ThingsBoard Cloud dashboard.
So now let's start with the node 1. So here we can see the code of our node 1, which consists of the different modules like sensor manager, actuator, config, network, telemetry. So now let's compile this sketch and generate its binary. So here we click export binary. Now for our node 1, we just load our hex file generated and click debug. So now we can see the data is uploading to the ThingsBoard. So here we can also see the dashboard in which that you can see the temperature, all the data from the thing from the PicsimLab. So we'll just increase the temperature to 45.2. Then here you can see the temperature is increased to 45. Then we'll decrease the humidity. Here it gets decreased with a little bit latency, but you can see it has been decreased. So if we increase the temperature all the way, it as it crosses the threshold, we can see our alarm which has been generated as high temperature. So we can just approve or delete this alarm. Now if we come again to the production line, which is the node 1, we can see the temperature values. Then if we click on the DST22 sensor and change its actual wiring from PD2 to PD3, which is a wrong wiring. So here you can see the sensor error alarm got turned on, and here you can see it's flashing as yellow, which is also warning, and machine status is off. But as soon as we correct the wiring from to PD2 with a small delay, you can see the machine status is on and the sensor error is off. Also, you can here see the all the data which gets updated every 5 seconds. So if we change the humidity, so here you can see new data will be showing. So 42C, 42, 53, 96, so data changed. Also the machine status which was 0, here you can see now it is 1. So as in here you can see all the data on the dashboard. Also you can see the switch control. As I turn off or on the switch control, you can see the light blinking. So now let's move on to the node 2. So here you can see the code of the node 2 with all the modules same as the node 1, but with some changes which are necessary as this is a warehouse part. So let's compile and export the binary, and then let's first load the configuration of the node 2, then load the hex file of the node 2 and hit debug. So here you can see these are the components for the node 2, like the PIR sensor we have used, then the door switch we have used to check if door is on or off, then LDR, then DS22. So now let's move to the dashboard and see the data. So here you can see the data. Let's, for example, let's decrease the temperature to, let's say, 5 degree, 6 degree. So with some delay, here you can say 6 degree temperature has been reduced. Now let's increase the humidity to maybe 60%. So here you can see humidity is increased to 60%. Also the time series graph you can see of the temperature values. Then let's see if clicking the door. Here you can see the door with some delay turns off. Again, if we switch the door, it says on. Then comes the time series table. Here you can see all the values. If we see the motion, let's go for the motion. We can see if we click on the PIR sensor with some delay, motion will be detected. So again, if we turn off, there is no motion detected. With some delay, it takes a little bit of time, but it updates the value. Till then, we can also see the same motion is turned off. So if we switch the switch it off, we can see here blinking of the LED. So this is the dashboard for the node 1, node 2, sorry. Here you can see the alarms also displayed for temperature high, as there was a high temperature above the threshold value. We can click it accept or we can delete it. This was all about node 2.
So let's move on to our presentation. As we saw the demonstration of all this project, the Smart Factory IoT system, now let's move on to the ThingsBoard UI. So also you saw in the demonstration how the UI was, how we can see the latest value, the time series graph, the alarm widget, all these functionalities we get into the ThingsBoard UI. Then alarms in the ThingsBoard. So herein we select the devices, we enter the message, then we filter them according to the script, like if it's less than greater than a particular temperature, the alarm will be turned off. Then we set it as a warning or critical depending upon the severity, and we get the alert at the dashboard and also the into the section of the alarm. So we can see that if it's red, the MQTT is disconnected. If it blinks yellow, as we saw, there is a DS22 read failure. Or if it is green, we can see MQTT is connected and there is no sensor data, as we saw on our PicsimLab. Now coming to the achieved statistics, that is testing. This is the major phase. In this internship, I learned about the most critical testing phase of an project. I tested the boot sequence, the sensor updates, motion hold logic, the door detection, dark detection, auto ventilation, RPC override, the MQTT reconnection, the sensor fault handling, and alarm creation by setting thresholds, setting the trigger values, and reconnection of the MQTT. This internship made sure how to make a system reliable and not just functional. Now, the key learning of this internship made me get to know about the Arduino embedded C, the file management, how it is done, how we can store the files in more format, then the PicsimLab simulation using the sensors, actuators, deploying the .hex file from the Arduino to the PicsimLab, then the reliability engineering, that is the sensor data which has a caching pattern to prevent false alarm by 10 seconds of hold latch prevent dashboard from flickering. The MQTT, the 256-byte MQTT payload changes from 128 byte, which is done via the pub/sub client.h. Then comes the ThingsBoard. The ThingsBoard, the rules which are being set via the threshold and the triggers for alarms. Then the dashboard design, selecting the widgets, adding the JSON files to an HTML code to the widget, and also setting up the devices which are in the added node. So to conclude this project, I'd like to thank the Emertxe team and faculty for providing me this wonderful opportunity. This combines the sensing, cloud monitoring, automation, remote control, and alarms into a complete IoT industrial solution. It was a very valuable experience to me. Thank you.